static partitioning. So you assign a set of machines to a static role, and they run a static set of services. For example, the front-end machine is always going to run Apache or a Rails application. So this there are some problems with this. One of the biggest problems is that this leads to unequal load distribution on the machines. So for example, if you have your front-end servers, you might have it busy running during busy with high traffic from 8 a.m. to like 12 p.m. And you have your cache servers which are which 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 are just using memory but not a lot of CPU. And it's not easy for you to move even though you have extra CPU on your front-end servers, it's not easy to reassign that CPU to your Hadoop jobs or your like Rails application or your services. It's also slower to add capacity to this setup. For example, if you are expecting a higher spike in traffic for like say New Year's Eve or Diwali event, you cannot and you want to have a 10% additional capacity to be ready for that event. So you end up bringing in, let's say, 2 or 3 more machines, plugging it in, setting up the hardware, getting it ready, which is in adding additional capacity becomes a matter of days instead of an hour, maybe 2 or 3 days if you have it processed down really well, instead of being a matter of minutes or hours. The other thing is that this static partitioning is also not fault. Uh, it's the mean time to recover from problems is higher, from issues is higher. So, for example, if you have a rack outage, like you lose 2 or 3 of your web servers, someone will get paged. He will come online and then bring back the servers, to and make them available for use. So, is there a better way to do to sorry. Is there a better way to to for to improve? Is there a better way to improve this situation? So here, instead of thinking in terms of static partitioning or silos, where like a certain server can handle will run only Rails or a Apache web server, is there so? For example, if you lose 2 or 3 of your front-end instances due to rack outage or power outage, Mesos can detect that failure and memory or code dumps. May have like a version 1 and version 2 of the same package running in the same production environment uh, and continue with your deploy without like interfering with each other. It also provides easier rollbacks, so that has helped our deploys as well. So that was a brief overview of what Mesos is. So the next part is about the service I migrated from a standalone host to Mesos. The service that I moved is called TCO, T-Running Service that's at 100%. So you're seeing this we do our what Apache application, you can create a Docker image for this, and Mesos can make sure that it starts up on the machine on like which has the resources to run the job. If this container shows problems, it will take care of stopping it, restarting it, and enforcing the quotas for that. But yeah, it uses a lot get throttled. So it's better to plan on keeping an eye on metrics and increasing the CPU or increasing the number of instances iteratively if you see throttling.
Hello, uh, hello,
Uh,
hello, hello. Can
yeah.
you hear me? Yeah. So I have like 2, 3 questions for you.
Sure.
So first thing you said about
Hello. Yeah, we're
Mesos
only
support.
allowing one question per person.
Come on, it's not
Yeah.
fair.
People have questions.
So you can
Sorry.
actually tweet out to me, and I can placement for Docker.
Okay, so it will provide a isolation of the applications.
It provides scheduling and part for that will give you a more
I'm not asking about contention. I'm not asking about contention,
right.
but Docker networking means like you have multiple
Oh,
containers on the same host,
right.
and you do natting to the port. But how do you actually connect? How does that auto discovery works in connecting to the exact container port? from an outside world?
Oh, so that is where you have like service discovery come in. So the port that you get assigned is dynamic. So you cannot assume that you are going to get the port. So what Mesos also does is that it talks to Zookeeper. So whenever your service starts up, you can say you can announce your service under Zookeeper path, and anyone who wants to like connect to your service, they can connect to that. Like they can query that Zookeeper path, and it will get back in the a JSON field with like host colon port, and use that to connect it. So if you use Finagle, Finagle is a library from Twitter for networking. It's a Java Scala based.
Could you hear me?
Yeah.
So,
Oh yeah.
do we have the Mesos cluster which you're talking about? Is there a central storage or something that's being maintained? If yes, what is the technology that's used for the central storage?
Sorry. Can you say it again, please?
Is there a central?
No.
Like a telco are usually like hardware failures, like routers going bad or like a switch going bad, and then they replace all that. Startups are a different beast. Like we work all day and churn out code and hoping users are going to like them, and so we move super fast. Depends on how much success the company is having, but usually like in the early days the scale is not so much, but change is really happening a lot, because as and when the business is trying to figure out like what they want to do, like they're releasing newer versions of their software, right? And then comes a web scale, companies like Netflix, Google, Facebook, etc., where features are getting churned out all the time, clusters are getting created and torn out all the time. In those kind of places, we see everything breaks, we see software failures, we see hardware failures, but still the end users get really high quality of service from the services they run. Like usually you don't see Facebook going down, or when you're watching Breaking Bad on Netflix, like you don't see Netflix going. They're more or less like running processes across networks, just that the cores are connected by faster interconnects than traditional networks, right? So now, instead of running a few reliable servers in the data center of 2016, we are just running tens of thousands of unreliable servers, and which is cool. We'll see like how we can, nothing new. And with microservices, typically an end user request fans out to 30, 40 odd services over the network. This is like how things used to fan out back in the day at Netflix. Netflix runs like 300, 400 microservices to power the streaming control plane on AWS. So once a request gets in a data center, like this is how the request fans out. Like this, all those things, all those dots out there are like actually individual mid-tier services or like nodes which are doing caching and things like that. So I have typically heard people say that monoliths are like a single point of failures. It's true, but in the new world, we haven't really gotten rid of our points of failures. Instead of a single point of failure, we now have amplified the number of ways things can fail. Like that's the reality. Like there is no silver bullet that microservices are going to make you more reliable, right? Instead, now you are going to be dealing with like other kind of issues. But again, at the same time, like with service-oriented architecture and microservices, you're going to get to the scale at which like you can run things for or tens of thousands of users or millions of users, right? So there are no silver bullets in life, and also in computing, there is no silver bullet if there was and steer traffic elsewhere in our across the globe. Then comes latency monkey. Latency monkey is the monkey which introduces latencies. Latency monkey is not very flexible. It doesn't use IP table and stuff. It binds with Netflix's the load balancer called Ribbon. So if you're using like a software load balancer, then Latency Monkey would work with that software load balancer and then make certain request phase over PET, but it doesn't work. Failure is like resolving TTLs and things like that, but that can happen. Make sure that like you can change like your DNS records from one service provider to another. It's not nice because most DNS providers don't play well, so their APIs are not that good, but you have to be ready for that. Like it's just really bad. You just need to know like who to escalate like when that happens. I don't have a good advice around that, but I have been in that situation. And we had to move that everyone knows like how to run maintenance on nodes, how to run maintenance on a service and things like that. And prepare runbooks and dashboards and not rely on tribal knowledge. Like, it's very easy to rely on tribal knowledge and say that my coworker has written this subsystem and only he knows how to handle that kind of a failure. All those things, all the knowledge that people have should be in runbooks and not in gray cells. So now, as I said, like, we are going to see how, like, we're going to talk about like how, now that failures are happening, and if you agree with me that failures will happen in production system, like, we will see like, how do we for the load balancer? And then parallel requests. There is actually a good talk by Jeff Dean of Google about like how Google takes care of the tail end of latency for end users. So what it basically means is that when a load balancer requests or when a client requests, it doesn't request one backend service. Protect, like, if something is taking too long, instead of getting the response back, use like a fallback, do bulkheads, and do aggressive timeouts. What bulkheading basically means is that if, for example, if you're on Java, if you're running using a thread for every request, then you are probably going to be using like a lot of threads as the number of request comes to that server, and what would happen is like the server is going to get busy. Instead of that, with bulkheading, like, you can limit the concurrency, right? You can say that I have a pool, and that pool is always making request using the client libraries and making network calls. So that way, like, if you're using a threaded server, like, you can get, like, you can sort of like save yourself against those issues. And timeouts, I think I've already talked about it. If something is too slow, there is no point in trying anymore. Like, you just like give up. Dynamic cluster schedulers. I mean, I work on dynamic cluster schedulers, so this has to be there in the slides. Use a dynamic scheduler like Nomad or Kubernetes or Mesos to use together. And there is this paper by Richard Cook, How Complex Systems Fail. I quite like that too. So thanks again, and let's open up for Q&A now.
Hi. Hello. Yeah, thanks for a great talk. The question I wanted to ask is, can you share any of the horror stories? How bad did one of these experiments go?
Oh, US West 2, and all our traffic is in US West 2. But then there will be like one team which would not know that we are doing that experiment, and they would start a deployment. And that deployment would mean that something has changed in the configuration, and it would basically break our experiment, and we would have an outage, right? And the other thing is that, like, if you're on Amazon and stuff, like servers don't fall from the sky, right? It's someone's data center that you are running on. So when you are increasing your traffic on one region and getting traffic out from one region and scaling up that region by 2x or 3x or 10x, like, sometimes your cloud provider might not even have that much machine. And what would happen is you have moved all your traffic now, and now there are no machines, right? Then automation failure in, for example, your persistent storage, right? You shoot down a node, you think that it's all cool, and then it's not cool because something broke, like your automation system couldn't handle it, and then you'd see like services going down, and you'll see like cache rates going high, and you'll see like for 15-20 minutes, like if you're a good team, like you'll have degraded experience. I mean, I can go on and on about like how things fail.
It has caused major outages.
Yeah, all this have caused major outages, but the good thing is that since we have that culture that systems are going to fail, and we build automation around moving traffic, so when something fails, it's easy for us to tell that, hey, you know what, let's not have anyone from New York, New Jersey to be pointing at this data center. Let's move all these people from East Coast to West Coast, because East Coast is where like most people live, right?
Yeah. So don't you also get into that confirmation bias? You're testing for the failures that you know, but missing out on something that is not obvious, which might cause a bigger issue. Right. You want to hear like a story related to that? So isn't that a common thing that you only test? Yeah, totally. Like we would see that, for example, like one of the services that we think are like really stable, and we would have no clue that this is something that is going to cause an outage, and we would do these experiments, and we will see, and I am given like a service which cannot withstand the move, then like we say to ourselves, hey, like we know that this is not something that is going to take like a whole region failing, and we are going to blacklist it, and hopefully like in the next quarter or something, like we can invest in making it move regions.
Like it's very common. Like you have to live with it. Like if you're starting fresh.
So let's say you're a small startup, you're setting up AWS, you have an RDS. The basic thing you can do is you can set up multi-AZ, right?
Yeah.
So that will ensure that
exactly.
It's one AZ goes down, you are still okay.
Yeah, exactly. And if you're also like using RDS, for example, like you need to know that you need to be like pushing your backups to like somewhere like S3 or having pushed your backups not even in AWS somewhere else, so that if everything goes wrong, like you can move like restore your databases in another region.
Yeah. Okay. Thank you.
Hey, great talk, Deeptanu. Thanks. So my question was around, you gave us an example of 300 microservices and your requests fanning out, right?
Yeah.
So how do you gain confidence in your release process?
There is just no release process. Like you release all the time, and you keep monitoring all the time, and you need to have a solid rollback strategy. Okay. Right? There is nothing like something to be like working really well. If you're writing software, if you have written decent software, like just release it and release it to like 1% of the users, right? Do a canary, like don't release to the whole world, right? And then see what happens, right? 1% of the 1% of like 60 million people, like it's fine, like it's the sky is not going to break down.
Okay. So essentially, you're recommending testing in production by
exactly. No, by testing, I'm saying monitoring and rollback.
Okay.
Right. Yeah.
Yeah. In terms of the simian army and so on, how do you test how those things function? Like, what's the testing for your failure generation systems?
Good question. I'm not very solid testing system out there. We just think that it's going to work, and we try to, we then basically like what we do is we blacklist everything, and then we whitelist only like certain things, and then see like how this works. And also like we can build like some things like dry run and stuff. So some of the monkeys have dry run, for example. And then you don't do it in production like on day 0, right? Like you do it on your test environment or staging and something, and gain confidence, and then move to production. Yeah.
Hey, back here.
Yeah.
So I had a question. So, great talk. And I think like a lot of these principles work really well for systems that scale a lot and have to be up all the time and all of that. But it all costs money.
Right.
So, like one thing that I would like to know about is when do you make that decision of I'm going to do this all the time?
Right.
Because just getting this set up and running is itself money.
Right, 100%. And totally agree. This is something that comes up very often. Like when do we become like Google or Netflix or Facebook, right? That's pretty much the question. I think like right from the get-go, like if you have that infrastructure in place, if you have the skeleton in place, right? Not use like a load balancer which doesn't have complex or nice load balancing strategies. Use a software load balancer, use a service discovery, right? Keep all the framework in place so that it's easy for you to like do incremental improvements in your infrastructure. Like that's like, I mean, that's the most pragmatic way to go. And again, like, you know, like I work at a startup too, like there is always a race between deploying features, and then there is always the race between deploying features that people are going to write and also strengthening infrastructure, right? Like you'll obviously come to that place if the business is working well, like you will concentrate on the service keeping up. So I think a lot of these problems, a lot of this discussions about how much money we are going to be spending, like I think goes away when the business does well.
Hello. Yeah, since you mentioned about service discoverability, can you tell some key points which we should take in mind while designing for it?
So service discovery is again like service discovery systems are very complex, right? Like you need to understand like what that service discovery system is doing, right? For example, Zookeeper, like Twitter uses Zookeeper, and they use Twitter Commons and server set and all that to write data in Zookeeper, and then basically use Zookeeper to understand like where things are. And like you need to know that Zookeeper is a CP system, right? On the other hand, like Console is also CP, like it has similar things going on. And Console uses Raft and Surf, which is like a variation of Swim, to basically disseminate information in the cluster. Like you need to know like what is going on under the hood in the service discovery system to basically know like how that system is going to fail. So now when you know that how the system is going to fail, now you basically query the service discovery system in that way. For example, if I am running Zookeeper, I am going to make sure that I have at least like Zookeeper 3.5 in production, So that like I have certain observer nodes and stuff like that, where even if there are quorum loss, like not Zookeeper still can give me like read, I can serve me read request. Same with console. Like if I'm doing queries against console, like I would do like a stale queries and stuff. I would keep the cluster size to maybe like 7,000 or 6,000 or something, and then connect them over the WAN or stuff. So that is there. If you're using Eureka, which is what we used at Netflix back in the day, it is an AP system. It doesn't have any failures like Zookeeper and console, but there are limitations in how many servers can connect to it. So then you need to size your clusters that way, like which is like 50, 60,000 servers. So if you're running more than 60,000 servers, then you need to deploy like multiple versions of Eureka. Does that answer your question? Cool.
Yeah. So, how do you think Terraform here will help in?
Sorry,
this?
I don't see. Okay.
Sorry.
Yeah.
How do you think Terraform will help in this monkey testing? Like
so yeah, so as I was saying, like I had a slide around the tools how you build a resilient system is use immutable infrastructure, right? And what happens is when you use immutable infrastructure, you need something to build those machines and to bring up your cluster. So for example, when something goes down, you can use Terraform to make sure that there are same number of servers when something goes down, right? So you can create your clusters using Terraform. And those Terraform configs will work across clouds and stuff like that. So mostly like around immutability, like Terraform and Packer helps. So Packer is what you use for building AMIs.
Okay, a lot of you still have a lot of queries. Please take them offline to Diptan.